This is a review of the new Trent PowerPak Ultra. It's a 14,000 milliampere power pack with dual ports. On the box it states that it's waterproof, dustproof, and shockproof, but I could find no IP ratings on the case. Inside the package you'll find a brief instruction manual with specifications and some details of operation, the battery pack itself, which is very ruggedly designed. It weighs in at 12 7/8 ounces because of how robust the case is, and a charging cable that's a USB to micro USB cable that is 33 inches long. The battery itself is a lithium-ion polymer design that's rechargeable up to 500 times. Its input to be charged in the manual and on the web page says 5 volts DC at 2 amps. In addition to that, on the second page of the web page it says 1.5 amps. But since the manual says 2 amps, I truly believe it, and I used a 2.1 amp source to charge this battery. I recommend that you use an AC wall source of 2.1 amps. Anything less than that will take a lot of time. The charging time is 9 hours at 1 amp by my calculations, and roughly 5 hours or so at 2 amps. And if you're going to use your USB port on your computer, and it's a USB port that's rated at 500 milliamps, it could take as long as 20 hours to charge. Here's a push button, and here you'll see 4 LEDs. When you press the button, it will tell you the charge of the battery. So if I press this and hold it, you'll see the LEDs light up, and you can see there's 4 of them. Each LED represents 25%, so the battery is fully charged. This same button has to be pressed when you want to start the charging cycle, and you press and hold it for 2 seconds to start your device charging. Inside here you'll see the charging input port. I like how they're all covered with flaps to keep out dust and dirt. And there you can see the micro USB input port, which is where you plug this cable in to charge the battery. And here you'll see output 1 and output 2. They're USB style plug adapters. Output 1 is 5 volts DC rated at 1 amp, and output 2 is 5 volts DC rated at 2.1 amps. So this one's ideal for charging your smartphones. This one's ideal for charging your tablets. Just make sure you take your cables for your devices with you to use in these ports. See how rugged this case is? It's very robust. You can see it's screwed together with metal screws around the outside, and they've got gripping surfaces here for your hands to fit into. It's just a nice design, very rugged, and I believe it could withstand even moderate dropping. An ideal battery for somebody who's clumsy, I hate to say that, but also it's true, or going hiking, camping, mountain climbing, or working on a construction site where you may bump it around. You can see I have my iPhone 5S plugged in with a cable, and I haven't turned the battery on yet. I have to press this button for 2 seconds, and you see it come on. The phone beeped, and it shows that my phone is charging at 0.6 amps, and if I flip the switch down, it's charging at 5 volts. I want you to know that it's plugged in the 1 amp port. The reason why it's not drawing 1 amp is that the current is normally regulated by the device that only draws enough current that it needs to charge itself at a reasonable rate and prevent overheating. During our testing, the battery remained cool at all times, never really got hot. You can see I plugged in the cable into the 2.1 amp port. I'm now charging an iPad Air, which likes to draw upwards of 2.4 amps if it's fully depleted. It's at 95%, so it won't draw that much. I'm going to turn it on by pressing the button for 2 seconds. And you can see it's charging at only 0.85 amps. That's because it's almost fully charged, and as I mentioned, it's going to regulate the current at once to slowly charge and not overheat and not overcharge. At the same time, if I flip the switch down, you can see it's still charging at 4.98 volts. While this battery is ruggedly designed, I have to point out not everything was perfect. We ran an efficiency test by using the battery to charge multiple devices, iPad 2s, iPhone S's, and we did calculations to determine the efficiency output of the battery. We were able to withdraw 8,794 milliampere hours out of a 14,000 milliampere hour battery, and that's a 62.8% efficiency. That's below average. I would have expected at least 70%. That still allows you to charge your iPhone 5S 5.6 full charges, but it's not up to the standard I would have expected. In all fairness, we then decided to run a second test. We then fully charged the battery again, letting it charge for 24 hours, and then we plugged it in, and then we charged an iPad 2, an iPhone 5S, and partially charged an iPad Air, and we were only able to get 8,463 milliampere hours, so that's 60.4%. The second test was actually slightly worse. Based upon those results, I would have expected at least a 70% efficiency, so the best I can rate this product is 4 stars. It's nicely packaged, it's rugged and robust, it's going to take a lot of beating, but its battery capacity and efficiency is just not up to par. I want to point out that when you use a battery like this, if you're buying it for its ruggedness, always make sure to close these flaps securely. Not doing so, the case will no longer be dustproof and waterproof. It was done by jjceo. I'd like you to know that I received a sample for test and evaluation, and I promise to give a fair and honest review.